Hello, in this video I'm going to show you how to automate your OOMMF simulation so that it displays and saves the outputs automatically. So I'm starting from what is essentially the Exchange Spring OOMMF OXS example, and that's the same example that I looked at in a previous video, and I'll show a link to that video in the description below. So what I've done in fact is I've saved my own copy of this example just because I'm going to be editing it, so I don't want to lose the original, and I've just saved that in this folder here called tutorial. And this is pretty much the same as the Exchange Spring standard example. So what I'm going to do to be able to automate the display and saving of it is I'm going to copy in a few lines, and these are just standard lines that you can use in any of your MIF 2.1 and 2.2 files. So I'm copying in these lines from a page on my blog, and I'm just going to put those into there. And I'll just save that as well. So let me just talk through what these lines do. The first few here, they create the destinations that are either going to display or save the OOMMF output. So in the first case, or the first line here, I've got destination my_graph mmgraph, and what that means is there's going to be an mmgraph instance called, well, with the variable name mygraph. Next line creates an mmarchive instance, and it's mmarchive which OOMMF uses to save the outputs, and that goes to myarchive. And finally an mmdisp destination called my_display. And so having set up those different destinations, we can now use those to either save or output the scalar and vector data of OOMMF. So first of all, let's see. I'm going to be scheduling these outputs. So in the first case, I've got scheduled data table. The data table is what stores the scalar data. So scheduled data table mygraph step 1, and that means that every one step or iteration there'll be an output to my graph, which up here we know is an mmgraph instance. Then the next line says schedule data table myarchive step 1. So that again is every one step, and this is going to go to myarchive, which is an mmarchive instance. So that means that the data table containing the scalar information is going to get saved every one step. And we can also do the same for the vector information. So here's an example using OXS time driver magnetization, and this is going to go to my display, but this is going to be every one stage. And similarly, in the final line here, OXS time driver magnetization my display step 1. So every one step it's going to go to the display. So what this means is if we load up OOMMF tcl sh OOMMF.tcl, we can load up OOMMF just like I did in the previous video. Load up that, and we'll load up the problem solver, the 3D micromagnetic problem solver, and I'll just move that up there. And now I'll go file, load, and rather than going to the examples, I'm just going to go to my tutorial folder, open this example, and here you see immediately, because in the MIF file we've said that we want these different outputs, OOMMF has automatically created a graph. It's created a display window, and also if we go and look in mmlaunch, we see also loaded, although it's not being displayed at the moment, is an mmarchive instance. So these three instances are available to us, so we can either save, display the graph, or display the vector information. So those are all loaded up. So now let's see what happens when when we run. And here we've not had to touch the output, we've not had to specify the destination manually, it's all been automated. So now if we hit run, immediately there's output going to the display viewer, and here it looks like there's nothing happening with graph, but just like in the previous video where it was set manually, we need to go and first of all, well, set an x-axis, and then we just pick some things to put on the y-axis. So I'll just go with mx, and let's have this one as well. Okay, so there's definitely stuff going on, we can see. So every iteration here, it's updating the graph. So it is moving, is updating as we'd expect it every step. So that's the display, but we also asked it to save the data table every step as well. So by default, unless we ask it to do otherwise, OOMMF will output the file or its saved files to the same folder that the original MIF file was in. And in this case, it's this tutorial folder. So lo and behold, if we go to that folder, here's the file that we loaded, and here next to it is this file xspring.odt, and if we click on that, so that's at 386 kilobytes. Here we go, 412 kilobytes. So it's the size of the file is going up because each iteration, each step, the file is being updated as it's being output to by OOMMF. And you'll notice that this file is called xspring.odt. And how does OOMMF know what to call it? Well, if we go back to this MIF file and we go into this block here, the very first line of that, it says base name xspring, and base name here just means what OOMMF will use for the output name. And in a future video, I'll look at that in a bit more detail because it's possible to be a little bit more fancy and use formatting and also include some level of automation in that. But for now, we can just remember to use put something descriptive in the base name so we can keep track of what our different outputs are. So thanks for watching, and please like this video if you've found it useful.